So, you have your System Super 23, or otherwise known as Time Crisis. You have your official Namco 24-volt solenoid Time Crisis gun. And then you have this thing. This is the V159 gun drive PCB, and essentially all this is a transistor arrangement. That's it, video over. No, you know me, I'm going to go into much depth about what this is and what it does. Basically, this is, well, the gun drive PCB, and all it does is, it's, for the most part, it just activates the solenoids in the guns. Yeah, so that's essentially all it does, and the other signals, like the sensor and the trigger, they just pass through to the connector. It does always, it does change the connector format, but, you know, you could just get two of these connectors and put them onto, you know, you could basically adapt the gun straight to the board and it would still work, you just wouldn't get the solenoid. And really all it is you can tell, it's just a really basic arrangement. This was from a Time Crisis cabinet, and you'll notice that it's only got the one gun input. This is the second gun input. Basically this is gun, these are the gun bits, and those are actually start buttons, although this is where your pedal would go. And yes, I would assume that Namco had the intention of making a two-player gun game. Time Crisis wasn't one of them, and I think Time Crisis was the only one actually on Super System 22. So, you know, this is basically, you'll only ever need this for Time Crisis. Do you need it? No, you don't even need to hook this up, really. If you don't have it, don't worry, the game will still play without it. It's not like an I/O PCB or anything. But if you want the solenoids to work, yes, you will need it, because the way the game works by default is all it does is send a signal out. It doesn't actually do anything, and all System Super 22 games are like this. It basically sends a signal out of the solenoid connector, which is a... let's see if I can find it. This is the connector board. This is actually called the mother PCB, but this is, as I'm going to call it, the connector board. All it does is have power in all of these connectors. Ignore these are for the boards. Basically, on the main PCB you'll have many different connectors. You've got, what was it, your communication, your switch, your switches, your audio out, JCM2. I think I have that about somewhere, and I'll see if I can get it up for you in a couple of moments. But yeah, basically all this does is adapt the game board to the game board to the Dubit. I can't think today. And what it is this board connects to the JGT connector, or J5, and that's your solenoid outputs, if I remember right. That's your output. It's got quite a few of them actually. I think this is output. What is it for the most part? Because this is your coin door connector, I believe. So yeah, the whole point is the game board literally runs the game and does all the processing work, and if it needs external components like an external fan on a prop cycle, or you know, solenoids in Time Crisis, or lights in driving games, it would basically just say to set a flag on this connector and say, I need this doing, and then the drive PCB would then do that. It's a fairly simple system, really. Really doesn't need a whole lot on the board. So basically what we've got on this board is an SLA 4060, which is a NPN Darlington transistor arrangement, and that allows you to have four transistors in there, and basically you can control 4 outputs. So you've got the start connector here, which is the pedal on Time Crisis, but it could have a start lamp, which is not used. You've got the solenoid, start, solenoid. That's all it does, really. So with this board you can control lamps and the solenoid, but you know, on Time Crisis only the solenoid really needed. Over here we've got a couple of resistor packs that literally pull up, so if I remember right. And then we've got a SN74LS04N, which is a hex inverter. And what a hex inverter is simply if you feed it a binary digit or TTL logic value of 1, it will invert it to 0. Sounds like a weird thing. Why would you want that one? You'll just have the game do it by default. But it's, you know, if you've already designed a system to do something, and this is an afterthought, what are you going to do? These PNP transistors will only activate when the signal goes high, or TTL1. And the way that most Namco boards work, and this is the same for point blank as well, I believe, is that it grounds the signal when it wants to fire the gun. Basically, and that's why they use a hex inverter to invert that 0 into a 1 to fire these off, because these expect a logic level of 1 to activate. So this is basically converting it. So because if it didn't, the solenoid would be constantly on during game usage. It would sort of, instead of sliding backwards and forwards, it would slide forwards and then backwards. So that's why that's there. And then you've got it's a coupling cap. No, it's just a standard cap. It's just basically a what value is it? 10 microfarad. You don't even need that really. So yeah, all that this board does is activate the transistors to allow the outputs to flicker on or off. I've got actually on my screen here, this is a document containing all the pinouts of everything to do with Time Crisis, and yes, it was written by me, as you can see up there. Basically, I've went through and made a list of all these different connections, what they do and how they work. So if we go and look at the gun drive PCB, you see we've got all the connectors there. So basically all this does is control the solenoids, like I say, and all this is a 24 volt input here, which goes into the transistor, the transistor array. I think it's called a transistor array. Well, I'm going to call it that. Then you've got your main board connection here, and basically this acts as a pass-through, allows the board to get power, and also allows the game to activate the solenoids. Like I say, it's an incredibly simple system. So when the game wants to activate the solenoid in the gun, for that brief second to activate the kickback function on it, basically it will pulse pin 6 on this connector to ground. It will bring it low, pin 6 being that one right there, if I remember right. Basically that then goes into the hex inverter, which will then invert that signal into a 1, which fires off the transistor array, and thus connects the connects the positive voltage of the 24 volt solenoid to the solenoid itself, thus bringing it back, and then follow the sequence again for turning it off. This bit goes high, this goes low, that turns off, solenoid goes back. It's an incredibly simple system. You do not need this PCB to make Time Crisis run, and as I've said, you only need it for the solenoid, and you can replicate it. These are off-the-shelf components. The SLA 4060 you can buy loads of different places. You could even use a relay if you wanted to, but that'd be kind of awkward, because then you need a transistor to activate the relay, and then you need to make sure it's at the right. Then you need to make sure you've got the signal inverted, which again you can do because you can buy hex inverters for a dime a dozen. And then these resistor modules just bring all the logic high. Again, going on this subject of why do you need logic high and low, and pulling stuff and pulling stuff down. This transistor, you do not want to leave the base leg floating. If you do, it doesn't know really what to do. Sometimes they'll fire, sometimes they'll activate, sometimes they'll disengage. You don't want that. These pull-ups, this is probably going to be a pull-up or pull-down resistor, and they basically set it into a known state. So, for the transistor, this would be a pull-down resistor. So what happens is when you want to, when it turns on, these will pull the transistor low, and it knows to be off. And when this goes high, what it does is it overrides the pull-ups and pull-downs. Basically, it will, if this transistor it's being told 0 up until this chip here takes control and then says actually turn on, and it'll turn on, and it won't damage anything because the resistor is there to stop current going through the, there's still a little bit of current going through, but electricity follows the path of least resistance, so it will follow the path that's easiest. So even though you've got 5 volt coming out the chip, it goes through the resistor. It could go through the resistor, but it's easier to go through the transistor. Anyway, So that's the basic of the gun drive PCB. You don't need it. And like I say, if you wanted to replicate it, all you need is a SN74LS04N or equivalent hex inverter, a couple of resistor packs, or you could even just use the standard what was it, half watt resistors? No, less than that, quarter watt resistors. You don't want to put in a storage cap for the thing, and then you just need a transistor. Really, you just need a single Darlington transistor, sorry, to activate the solenoid. You just connect the base. You want to connect the base to the hex inverter to whatever pin you've connected to your main board. Then you just connect the collector and emitter to positive on the the input and the positive of the solenoid, and you're good to go. Simple board to replicate. You don't need it, but needed for the functionality of the gun. And if you've got something like a 12 volt gun, you can just feed 12 volt into here. It still work fine, and then you can use the 12 volt solenoid guns. Because remember, not all solenoids are 24 volt, and if you connect a 24 volt power supply to a 12 volt solenoid, that solenoid is going to go bang. Anyway, 11 minutes. That must be a record for a shortest technical video. And like I say, simple PCB, don't need it. But if you wanted to get the guns to activate, yeah, that's all you need. So I hope this video has been informative. Hopefully you've not tuned off halfway through, like I think some of you do. But yeah, that's just basically how that system works. So thank you for watching.